Hello and welcome with another video. I'm Professor Dr.Mchem from, of course, my office from Dr.Mchem Institute of Chemistry, University of St. Jamshoro. My students know me very well because I've been on this YouTube since last almost 2 years. So today, though I have almost lost interest in making videos because my students are not at all interested in watching whatever I'm teaching. And besides teaching, if I say if I give remarks on any other topic or in any other thing other than studies, I can see a lot of views. That means you people want only entertainment. But I'm very sorry to say that I cannot entertain you in that way. There are many other channels you can go for that. This channel is purely for academic purpose and purely for my own students who are very much serious in their studies and in making up their future to become something, right? To become a successful person in their lives, or to achieve something in their future. So I'm here very much here to help them out. Today I have selected a very simple topic because I've been you can see this, what is in my hand. This is a glass rod, right? A glass rod. I've been there are many types of glass rod. There are many types of stirring rod. It is also called a glass stirring rod. It is used for stirring or agitation and for agitating a liquid or for mixing a liquid in the labs. And now I have seen students using this in different ways in the laboratory, and they of course they know what it is, why it is used and for what reason it is used in the labs. But basically these are the glass rods and they are used for the stirring purposes, and they are also, besides stirring, they are used for decanting a solution from one container to another. When you have some product in your beaker, you have prepared something and you have some product in your beaker. Now you want to pour the liquid and keeping the product precipitates that are formed, never to disturb those precipitates. You just want the liquid to flow into some another container. That means, so you will simply hold it in some way. You will hold the this rod in such a way inside that container that it won't let the precipitates fall into your another vessel in which you are transferring your liquid portion only, right? Because you have the precipitates and you have the liquid portion, that is the solvent in which you have precipitated your compound. So it is used for the decanting also. And so there are many other types of stirring stirring rods, right? There are many other types of stirring glass rods. And besides glass, there are also other types, that is Teflon rods, that are Teflon stirring rods. And there are many other types which I have today selected this topic for my students, because mostly in the lab I've seen that students are holding spatulas, metallic spatulas, and they are of course we can use steel body, a metal body for stirring purpose also. But not when you are dealing with your pure organic solvents, because organic solvents are very volatile in nature, and they can interact with the metals that are with your metallic spatula. So you need to be very careful when you are dealing with your organic solvent. So you need a glass stirrers for mostly when you are dealing with any organic solvent, or for or you are dealing with the different solvents that are volatile in nature, that are hygroscopic. So you need to be very careful. And I hope everyone knows what are organic solvents, because I've been repeating this for in my many lectures. I've been repeating this, and I select a topic referring to your lab work, because I am with you in the lab for a very long time, and I am teaching in the laboratory more as compared to the theoretical classes, right? So and I think that is also the one of the very much positive points for a professor who is supposed to be in the So professor is supposed to be in the lab work more as compared to the teaching side, because professor gains a lot of experience during the whole time period. I mean, reaching to that level, the last level of its academic career. When you become a professor, that means you have the full command on your when you are on your subject, of course, and on the practical side, you have got the mastery over your practical hand. You know instrumentation, you know that, I mean, the different type of reactions that are going on, you know the basic theory that is behind that reactions, and you know why that is happening. So you can teach the students more in a much better way, rather than taking a simple theory, conducting a simple theory class. So that's why I prefer lab work more. So that was all about me. I'm not discussing myself today in the video. I'm discussing about the rods. So let's move towards the whiteboard so that I can move on with the, of course, with my lecture which I was supposed to deliver today. And I hope that it will work out with you people the same way it will work out for my other students. So let's move towards the our whiteboard. So as I was just telling you, we are now going to discuss different type of agitations or starting methods. So this is basically the topic I've selected is mechanical agitation, or how it is useful, how it is beneficial. It is beneficial simply when suspension of particles, that is this one, suspension of particles is made, right, in a solvent for what? For progression of the reaction, for progression of reaction. It is also called mechanical stirring. It is also called mechanical, mechanical, mechanical stirring. It is not required when we are dealing with homogeneous mixtures. Keep that thing in your mind. Why when we don't need it when we are dealing with some homogeneous mixtures. Not required. It is not required when you are dealing with what? With homogeneous. I hope you know what is homogeneous. What are homogeneous mixtures? Right? So, but only it is recommended when to mix a compound in a small portion, right, or in a dropwise manner. When it is recommended, when the simply when you what you are doing, when a compound you are dealing it is in a very small proportion, it is in a small portion, or the addition of that solvent is in a dropwise manner or in a dropwise manner. Now my students will know what is a dropwise manner, BS Part 3 and MSc previous students, because I have been explaining it to them how to practically. I've shown them in the laboratory how you can mix one solvent into another in a dropwise manner slowly, right? So this is the time when it is recommended strongly when you are going to mix a compound in a very small portion, or in a when you have the quantity of that solvent is very small or little, or you are in a dropwise manner. Now why is it so? What is the reason behind it? It is just because, why? To let it in contact with a greater quantity of solution, right? Why? To get it in the greater quantity of the solution. To get it into the, why it is happening? What is the reason? Just to let it in a contact with a greater quantity of the solution, with a greater quantity of solution. When you have the solution in a large quantity. And what would be the result of that? Usually it results into precipitation. What? Into precipitation. Resulting into the precipitation of what? Of the desired product. Of desired product. Now during this process, the vessel or the container gets warmer, right? When you are doing it, the vessel or the container, either if it's a beaker or if it's a conical flask or Elmer flask, it gets warmer. I can show it like that: warmer, hot or warm, right? Now what that warmth indicates, why it is getting hot, it is indicating an exothermic reaction, indicating an exothermic reaction. When you are holding the vessel in which you were mixing the two solvents together or two compounds together, and if you feel the vessel is, the beaker is hot, right, or it is warm, its outer wall is warmer, or its outer you can say that the wall, this is getting warmer or this is getting warmer, that means this type of a reaction that is going on between them is an exothermic reaction in which the heat is evolving out, right? So this can result in what, of course, in the decomposition. When this happens, what it results in the process of decomposition, right? And of the prepared desired compound, So this is the reason, that's why the solution is continuously or constantly supposed to be stirred. That's why a constant solution inside the vessel is supposed to be stirred constantly with a glass stirrer or with a rod. Constant stirring is required, right? A constant stirring is required this way or this way, right? It is constantly stirred just to avoid this exothermic type of a reaction that is going on. So it is constantly, stirred or agitated. One other word is stirred or agitated. Someone says, what is agitation? It is simply stirring of the compound. And this agitation, it can be, of course, manually, that is, you are shaking the vessel like this, or you are stirring it like this. This is called manual stirring, right? So this is called manual stirring. Or by mechanical agitation. Now there are other methods also in which you have the magnetic stirrer, in which there are many, there's a capacity of keeping a number of bottles in one stand. It's a stand like thing, and it is it's a little bit, it is plugged into the electricity, and it's a mechanical, and you do not need to do it manually. It keeps on shaking up and down, or right or left positions. So there is another way also, that is, the mechanical agitation. So now mechanical agitation is recommended. Now when it is recommended, when bulk of the compounds or large quantities are mixed together. Usually we use mechanical agitation when you are mixing, when there's a bulk of compounds, there's a huge quantity of compounds that are going to be mixed together. So they need to be agitated with the help of a mechanical stirring or so it also helps in when you why this mechanical agitation is needed or recommended. I've explained you when you are using, larger quantities are mixed together, and it also helps in the expected reaction time to be lessened. The reaction period would be lessened. It will be the time would be less as compared to the before that agitation, and with controlled temperatures. Of course, when you are using the mechanical agitation, you'll be using the temperature to be controlled by some sort of by recording its temperature or monitoring its temperature range, and what will result in the end, and a good amount of product is formed. Now I will show you in figure 1. I'm going to make a figure in which I will show you a stirrer. Now this is a figure of stirrer, which we also call it a general purpose stirrer. Now it has got a motor of about 1/16 HP motor. It has got a 1/16 HP motor, and it is you can see there's a stand over here. It is assembled with the help of this stand, and it can be assembled with a retort stand or a clamp stand. This is a retort stand or a clamp stand or a ring stand. There are 3 to 4 types of stands: clamp stand, ring stand, or a retort stand. Okay, so of course for supporting this glassware, this stand is used, and we always assemble our assembly in a nice way, assemble our glassware in a nice way, and clamp with the help of clamps. There are clamps over here. So and all this is done just to support, of course, this glassware, this assembly, right? Now for this you need to hold it with the help of rubber tubings also. There are rubber tubings, and mostly rubber tubings are used for glass stirrers, right? When the glass stirrers are used, they are used because they are a bit thicker, right? They have thick walls, so rubber tubings are used. Other types of stirrers are also there, like steel ones, or that are of course attached with the help of a screw. The rubber tubings are used only for the glass stirrers, when you are using the glass stirrers, but when you are using the steel ones that are made up of steel, you need to screw it. You need a screw to assemble it or fix it. Now here I would like to mention one thing, that when this is happening, the speed matters also. So the speed is monitored and is controlled by an instrument called rheostat. RHEOSTAT, a rheostat. So it is simply employed to mix viscous solutions. Rheostat, right, in this type of things are used to, they are employed when you are dealing with very viscous type of solutions. So this is rheostat. It is only used for monitoring or controlling the speed of the stirring instrument, and it is run by, of course, by electricity, right? So, and it controls the current. What is the function of this rheostat? It controls the current, right? So stirrer is an important lab glassware. Now we should keep this thing in your mind, that stirrer is a very important glassware. Where is the stirrer? I'll bring it. This is the glass stirrer I have in my hand. The stirrer is a very important type of a laboratory glassware, and these are of number of different types, right? The stirrers are of different types, like glass stirrers and like others also. I'll explain you in a second. So if you come to the types of the stirrers, these are the different types I've written here: the glass stirrers, the steel stirrers, the Teflon stirrers. Now why Teflon? Teflon is used, which is a bit soft, right? And it's a bit soft, and it is basically used for in the refluxing methods and for stirring the mixtures, right? Because stirring the flasks, because it is not that much, Teflon is a bit softer, right? So that's why it's used in such type. Okay, so just because of its softness, it's used. Whereas this, if we talk about this Hirschberg, the next is Hirschberg stirrers, right? They are basically used in what? In the round-bottomed flasks. In round-bottomed flasks. They are basically used in round-bottomed flask. What is a round-bottomed flask? I can show you here. This is it has got a round bottom. This is a round-bottomed flask. This is a round bottom flask. So this type of stirrer, Hirschberg stirrer, is used basically in the round bottom flask. I will show you in the figures. I will draw it for you people so that you can see. Okay, and then if we talk about the mercury sealed type of stirrers, They're also used for, you can say they're used for the refluxing and for stirring flasks, right? Because they does not bend and strike the glass even at very elevated stirring speed. When the speed is very high, the stirring speed of the instrument is very high, it will not hit the glass, or it will not strike the glass even, and can be reshaped according to the glass vessel type. Now there are some figures I'm going to draw here to show you different type of stirrers. So now these are the, you can see different type of stirrers I have made for you people to see, right? They are the all glass stirrers, and I have named them also. They are used in the laboratories, right? And they can even be made, this one, they can be easily made by a student. Even a student in the lab can bend the glass by heating it over the flame, or heating it over a hot flame, and you can bend it in your with your desired direction in which you are supposed to use the direction, the desired shape of the stirrer you need. So you can make it on your own also. A capable student can make the stirrer of its own choice or of its own shape to be needed in the recommended experiments, right? So this one is a Teflon type, which is also called you can say stirrer with a half moon. It is called a stirrer with a half moon. This is a half moon, right? So this is a little bit softer, right? And you can also see another one that is a Hirschberg stirrer, which I have told you before that it is used mostly in the round bottom flasks for stirring and for agitation, the mixtures. So this is also, and this one I have written also. It can be inserted. It has got such type of a movable shape that it can be inserted into the vessels that are very narrow. Narrow means that vessels that have narrow necks, right? Such type of vessels, it can be used, that has got narrow necks, so it can be inserted inside them easily. So these are the different types of stirrers that I have explained you, and they can be shaped to simply fit inside the bottom of any vessel you need. And it will be of, it can be used for stirrings, even the very small amount of liquids, and even the large amount of liquids in the flasks, or solvents in the flasks. So, and this is, I think, I have drawn, and now you know what is a Hirschberg stirrer. Now you know what is simply a different Teflon type of stirrers. What are the stirrers that can be made by the students even in the lab? What is a half moon stirrer, right? What is a Hirschberg stirrer? So I hope you liked today's video, and you got the knowledge of different type of stirrers that can be used in our laboratories for in the progression of any reaction. Thank you very much.